All right, guys, thank you for coming back. Um, Here are some of the problems that we're going to start with. Okay. Once again, I know I'm repeating myself. These problems are from your text from 2.2. All right. Um, I think I have assigned similar problems in MATLAB, very, very similar, not identical. I can go back to MATLAB and do some of them, but that's really your homework. Moreover, the homework problem that I will do on MATLAB, even if I did, would look different to you. So everybody gets a different number. So that's out of the picture anyway. So I won't be able to do your homework for you. So these are the types that have been assigned. Another thing, when you do your homework problems, whether you do some from your book or you do the ones from your from MATLAB. Read the language very carefully. Make sure you understand what they're trying to say. So I'm going to read it. I don't know how small the font is, but I'm going to read it. Point P has coordinates x and y is the point on the unit circle. When they say they assume you know what they're talking about. That last point, the green point on my circle, has those coordinates, corresponds to a real number t. Real number t is the length of the rope. Find the exact values of the 6 trig functions. So I am going to take number 19. It seems hard enough. And I do need a little bit of room, so let's see how I can do it. Again, guys, keep the language straight, okay? So let me do this. Let me copy this question here, type it out. So this is 2 times square root of 2 divided by 3. So I'm just going to work on number 19, and you're going to see it's really an easy problem because it's one of the first ones we're doing. I don't think if you understood the definition, I don't think chapter 2.2 will be that difficult for you. All right, so I'm going to get rid of this because I need the room. The language is here. P is the point on the unit circle that corresponds to a real number t. Find the exact values of the 6 trig ratios. Okay. Now I'm gonna leave this here. I will try to draw the picture again. It's gonna, well, let me see the best way of doing it. Give me 1 second, guys. I'm gonna grab a unit circle from my notes. That'll save us a little bit of time. Okay. I should have some. If somebody's talking to me, just clearly say, "Hey, I have a question." Don't worry. All right, guys. I'm gonna just grab this if you don't mind. Okay. You don't have to. Okay. So suppose this is my unit circle. All right. Um, Suppose now this number, they're calling it P. No, right, I have to write P. All right, guys. So this x coordinate is positive, y coordinate is negative. Here and here, the y coordinates are negative. Okay. Where is x coordinate positive? Here and here. X coordinate here and here are negative. The y coordinates are positive here and here. The y coordinates are negative here and here. And you have to understand that. So I'm going to bring this point and write it somewhere here. It doesn't matter where you put it exactly. It really doesn't matter. You should put it in the right quadrant. So I'm going to claim my point P somehow is here. And you can use your calculator to calculate this little point and say, oh, this is about 3.5. It should be right here. Now, I know it's if this is 1/3, negative 1/3, it probably will be somewhere here. It doesn't matter, okay? As long as you're in the right quadrant, you are fine. Now, this little thing, the rope, the so-called rope, goes from here, and my drawing will be bad, and ends here. The same rope story, okay? The rope always starts here, and the end point has x and y are the 2 coordinates, okay? They're calling the length of the rope T. T as in toy. All right, fine, no problem. I didn't do a whole lot really, guys. All I did is basically represented the problem pictorially. Okay, now, fine. Now I'm going to find sine t, cosine t, and the whole shebang. How do I do that? Well, let's start with, I like cosine. Is the x coordinate? I generally start with that, okay? So cosine t is simply the x coordinate. That's all there is to it. And they're giving you the x coordinate, okay? They're giving you the x coordinate. This is not something you can just punch in your calculator and say, oh, I got it. You have to kind of know what you're talking about. That's it. Cosine t is this. Now I'm going to find sine t or determine sine t. Well, that's also not too difficult. Sine t is simply the y coordinate. Okay, that's easy. Okay, done. How bad was that? Now, um, tangent t and cotangent t. And I'm going to write tangent t here. Tangent t is sine over cosine, not the other way around. And I'm going to try to do my sketch work here. The sine, scratch work. Sine over cosine. Now you have two fractions, okay? This is minus. Don't ignore it. If the denominators are the same, when you're dividing, you can cancel them, okay? What are you left with? Negative 1 over 2 over square root of 2. Let's come here. So what am I left with? Negative 1 over 2. I'm going to show you the whole thing. Don't worry. That's your tangent t. So let's pause here just a little bit. So again, cosine t is very elementary. Sine t is very elementary. Elementary means you have to know how to do it from scratch. And tan t is based on sine t and cosine t. Those three, you can say they're elementary. Okay. And the rest of the three other trig ratios, the three, secant t, cosecant t, and cotangent t, are just these guys flipped, reciprocal. So I'm going to get rid of this, if you don't mind, and I am going to do it here. Okay, that's not really that difficult. Doesn't matter which one you want to do first. Secant t. Secant, remember guys, secant is the reciprocal of cosine, and I'm just going to look at my cosine and just write it. Now, I sometimes mess up, so be alert, okay? I don't do it on purpose, but I have, written 3 when I wanted to write 2. Secant is the reciprocal. I'll try to double check. Secant is the reciprocal of cosine. So far, so good. And cosecant is the reciprocal of sine. Reciprocal of sine is going to be 3 over 1. I'm just going to write 3, but don't forget the minus sign. Cosecant is this. And cotangent, we don't write cotangent, we write cot. Sorry. Cot is the reciprocal of tangent, where the denominator becomes the numerator, which is this. And don't forget the minus sign. Done. Again, if you understand the definition, it's not a difficult problem at all. You can see problems like this on the exam. And just to let you know, you want to watch the video that I shared with you on day 1 in terms of how to enter things online correctly. A couple of you asked me where the exam would be given. It won't be given in the Math Lab environment. It will be given in the BlazeView environment, which is really not that difficult. And before exam 1, I'll kind of go over it a little bit on the last day. So no worries about those things. There's no way you can write these things using your regular keyboard. It doesn't look nice. And not only that it doesn't look nice, you will mess up. You'll mean something and write something else. So let's pause here a little bit. You should be able to do that whole cluster. The whole cluster that is this. Really, they're all the same. Let's go back and pause here just a little bit, okay? See if you guys have any questions. If I messed anything up, you're going to correct me. All right, let's look at the next cluster. I seriously doubt we can wrap up the whole chapter today. Okay, find the exact values of six trig functions of the given angle. If any are not defined, say not defined. Okay, so guys, I'm going to take a little bit of time here on this one, okay? Why? Because even though it's one cluster, oh, actually, guys, we have to know something before we can even do this. Let me think. 60, 120. Yes, we have to know something. No worries, no worries. Let's go back and learn a few things before we can do this one. So let's go back. Let's go back to our lecture a little bit. All right, guys. So, all right. I don't think this is really that hard, but it's something people find a little challenging. And this is something you really want to kind of understand as well. I'll go over it in detail, and it's quite likely the way I'm seeing. I won't do too many problems today, but you want to get this. All right, guys? All right. So we're going back to our lecture. We did one cluster of problems, so you'll be able to do some of them. So guys, we are going to see that, let me take this guy here. Well, coming back, take this guy there. All right, so I'm going to take this to our main page to do some problems. Okay, you may have seen this in high school, not middle school. All right, guys, so this is a right triangle. This angle is 90 degrees. If the hypotenuse, what is the hypotenuse? A fancy word. I'm going to spell it today. I'm not going to spell it every day. Hypotenuse is the side that is opposite of the 90 degrees. Okay, fine. If this is 1, we can find this leg and this leg. By the way, the question says this is 45, this is 45, this is 90. Three angles of a triangle always add up to 180. If this is 90, then those two, if they're supposed to be the same, they're saying they are, better be 45. That makes sense. So I'm going to find out what this is. And I don't need to show you right now. I'm going to hide it. You're going to find out what it is, and it's going to turn out to be what I'm trying to hide, but you want to see it. So I'm going to say this is X. Since it's an isosceles triangle, this side and this side are the same. How do I know if this angle and this angle are the same? The side lengths will be the same. This is X. Remember the Pythagorean theorem? Again, I'm going to write it down, but not every day. The Pythagorean theorem allows me to write this. The square of X plus the square of X is equal to the square of 1. And square of 1 is 1. And x squared plus x squared is 2x squared. Things are already looking much better. I'm going to divide both sides by 2. I can do that as long as I do it on both sides or to both sides, I'm good. Now, I'm going to find the square root of both sides. I'm going to take the square root of both sides. If I take the square root of the left-hand side, I get x, because square root and square, they cancel. If I take the square root of the right-hand side, I get square root of half. Now, and that's good. We're good. Now, square root of half, when you square root half, you have to find the square root of 1, which is 1. And then you have to find the square root of 2, which is, we're going to be exact, which is going to be this. That's exactly what this is, guys. That's exactly what this is. I'm going to hide this. That's what it is here. Okay. So you can write 1 over square root of 2. Oh, I see what they're doing. So guys, some people don't like 1 over square root of 2. They don't want to see a radical sign in the denominator. I'll give you credit if you leave the radical sign in the denominator. The question says, rationalize the denominator. If it says rationalize the denominator, you have to rationalize it. So how do we rationalize it? Well, you can multiply both top and bottom by square root of 2. So let's do it. As long as you're doing the same thing to the top and the bottom, multiplying it by square root of 2, and you have this on top. 1 times square root of 2 is simply square root of 2. All right, what's square root of 2 times square root of 2? That's 2. Square root of 3 times square root of 3 is 3. So we have it. So you can say that in this triangle, if 1 is the hypotenuse, the other 2 sides must be this or this. You can say it either way. You should know that they're equivalent, and you have to remember this triangle. There are 3 triangles like this, actually 2 more. This is the first one. In an isosceles right triangle, if the hypotenuse is 1, the other 2 sides are, as it shows on the slide, 1 over square root of 2, or if you want to rationalize the denominator, square root of 2 over 2. Okay, I'm going to pause it just a little bit, see if you have any questions, okay? Okay, guys, so we're going to do something very, very similar with one more triangle. And the good news is the next triangle will do 2 things. So this triangle, this picture is associated with 45-degree angle. Okay, and that's something we will see a lot. All right, one more. So guys, this is an equilateral triangle. Each angle is 60. This is 60, this is 60, this is 60, and this is 60. And the sides are 1, 1, 1. I know I didn't write 1 in the bottom. So if I drop a line like this, and this is a right angle, this is 90 degrees, and this is going to be 30 and 30. Okay? Because it's 60, it's going to divide it into 2 equal parts. So I am really interested in this half. This half is what I'm looking for. This is an equilateral triangle whose sides are 1 unit. Okay, all the 3 sides are 1. That's why the base is going to be half. And this angle is going to be 60 divided by 2 or half. Right, my goal is to really show you guys that this side, this vertical line here, will be square root of 3 over 2. And this is half, it's easy because this whole thing is 1. This is going to be half. Well, that's easy. I'm not trying to convince you. This angle is 30 because this is 60. It's going to be half. This is 60. That's 60. This is 90. So I'm looking at this right triangle. Okay. Now I'm going to call this side X. I'm going to call this side x. And I'm going to apply the Pythagorean theorem to show that it's square root of 3 over 2. Well, let's find out. How do we do it? Well, that's not really that difficult. Hypotenuse square, half square, x square. Doesn't matter which one you write first. Okay, Pythagorean theorem like before. And half square is 1 square over 2 square. I'm just going to write 1 over 4. I want to simplify things. Is 1. Now, I'm going to subtract 1/4 from both sides as follows. And 1/4, and you really have to understand fractions in this class, okay? You're going to see half of trig is knowing about fractions. 1/4, if you take away 1/4 from 1, you're going to get 3/4. And like before, we're going to take the square root of both sides. If I take the square root of the left-hand side, the square and the square root sign will cancel, and I will be left with an x. And this one is going to be this. Now, remember, guys, when you have a fraction and you're taking the square root of the whole fraction, you can separately take the square root of the numerator, take the square root of the denominator, and write them as follows. Square root of 4 is 2. Done. And that's exactly what we had. Square root of 3 over 2. So you have to know this kind of a right triangle, 60 degrees, 30 degrees, and if this is 60 and this is 30, you are going to have a triangle that is 1 on the hypotenuse, half on the base, and this is called the height. Square root of 3 over 2 is your height. And you want to have a copy of this triangle somewhere in your notes, all right? Otherwise, you won't be able to work on some of the problems. Just these two triangles. The good news about this triangle is handy when you're looking for 60 degrees and 30 degrees. And the other triangle, this one comes in very handy, sorry. This one comes in very handy when you're going to be dealing with 45 degrees. Another piece of good news, we will be mostly dealing with 30 degrees, 60 degrees, 45 degrees. Okay? Now, let's go over one tiny thing. This is something you want to know by heart. Okay, 180 degrees is equal to pi. Why do you need to know it by heart? You can write it down. I don't have a problem. But if you don't know it, you won't understand the problems. You won't be able to process. 90 degrees clearly is pi over 2. Clearly. Okay. What about 45 degrees? Well, that's 90 over 2 or pi over 4. Okay. Start with this. Start with this. Divide both sides by 3. 3, you're going to get 60 here. And there's going to be pi over 3. And take this. Divide both sides by this times 6. If you divide this side by 6, you're going to get 30. You're going to get pi over 6. Okay. Now, you knew this before today, and you could have calculated these before today, I'm sure. But you want to have it imprinted in your brain. When you see pi over 3, you should see 60 degrees lurking around. When you see pi over 6 radian, you should see 30 degrees lurking around, and vice versa. And pi over 4 is 45 degrees. Pi over 2 is 90 degrees. We'll mostly be talking about these 5 angles. And of course, there is 0 degrees, which is not even worth mentioning. 0 is easy, right? Everybody knows what 0 degree is. Or 0 degree is 0 radians. So that's easy. So I wouldn't mind stopping here. Next class, we're going to do something a little more difficult, and that's one of the issues with online classes, guys. So let me explain this to you. I know we're given a little extra time, but if you don't allow these ideas to gel in, you're not going to understand the next difficult topic. So the next thing we're going to do is going to be another hard topic. Hard today we encountered one difficult topic. It's very difficult to do two difficult topics in one lecture where I'm just talking and I don't have a way of finding out how I can give you practice problems. So I'm going to stop here and you can always come back. I will be around for another 30 minutes for you to take questions. Some of you do come back and talk to me. If they ask me something good, something worth recording, I will record. If they don't, I won't. But we have two sets of lectures today. We spent about 1 hour, about 55 minutes or so. Again, bring some good questions from MATLAB. Bring questions from notes. If you have something you're working on in your book, you want to send me a snapshot, I don't get it. All those things are good. Okay. So I'm going to jump out of this session. I'm going to record things and upload things on BlazeView for you guys, basically the videos of today's lecture. Other than that, I'm done. Goodbye. But feel free to come back. I'll be around. Thank you, guys. Bye.